Alright, good morning. I hope we are well. So, the other time we learned that when we are given a Pythagoras theorem, like when we are given a right angle triangle and we have what any of the two sides, we can find the other by using what a Pythagoras theorem or what trigonometrical ratio. So, we used Pythagoras theorem to solve this very question. To solve this question. Let me bring the question here. We have for this right angle triangle. When is disturbing? You have this right angle triangle, and we're given here to be 8 units. Let me say 8 units, and we're given here to be 4. Now, here is A, here is B, and here is C. So we want to find this side. Let's say this side is what? Is X. Length what? Length AB is what? Is X. Here was given as what? Or here is given as 60 degrees. So we can use Pythagoras theorem or what? Trigonometrical ratio. This is opposite because the angle is facing this side. So we want to find AB. This is the same question. So we used Pythagoras theorem and we had what? 6.9 centimeters, which is approximately what? 7. So we want to use trigonometrical ratio, which is so, ka, and what? Twa. This is so, it means sine. This is ka, it means cos, and this is twa, it means what? Tan. So we use sine when we have O and H, which is opposite and hypotenuse. We use cos when we have what? A and what? H, which is adjacent and hypotenuse. We use tan when we have what? O and A, which is opposite and what? Adjacent. So with this question, we are interested in this one. So we can see that when we want to use the trigonometrical ratio, we should have at least 2. So the 2, we will take the one which we are looking for and any other one which was what? Or which is given. So we take this one, and either we take this one or we take this one and we take this one. Any of them will yield us what? The same answer. So with the trigonometrical ratio, let's continue from here. Let me say I have what? I want to use this one and this one. So if I have this one and this one, you see one is not what given. So we use this one, and this one. We were given this, so it will left with this. So what we do is we have this one and this one. This is what I'm using to find what this. This is opposite, so we have O, and this is adjacent, so we have A. So when we have A and O, or O and A, we use what? Tan, which is twa. So when we come here, we have what? Tan, and the angle given is what? 60. So tan 60 is equal to OA. O will come first and what? Or will come to the top, which is the numerator, and what? A will be what? Denominator. So OA, we are dealing with what? When we are dealing with the SOHCAHTOA, like those lengths, which is the adjacent, opposite, and stars, we do it what? Ratio. So O will come top, and O is opposite the X. So we have X over here over A, and A is what? 4. So this is like equation involving what? Fraction. Like let me say linear equation involving what? Fraction. We want to find X. So we just multiply what? 4 by this. We are doing cross multiplication. because the whole of this thing is over 1, but we don't write. So this one will multiply this one, 1 multiply this one will give us x. So we just multiply this by this so that we can eliminate what? 4 from here. So when this multiply this one will stand alone. Then we have x is equal to 4 tan what? 60 degrees. Then you just punch 4 tan what? 60 degrees to get your x. Simple as that. So we have 4 tan what? 4 tan 60. And we can see 4 times 60 is what? Is equal to 6.9. And 6.9 is what? Is approximately what? 7 what? Units. So it's 7 units. Just as we got over here. You see, initially we used Pythagoras theorem, and we had what? 6.9, which was approximately what? 7. And when we use the trigonometrical ratio, the tan, it gave us what? 6.9, which is also what? 7 units. Now let's take it from the other what side. At first we use this one and this one. We want to use this one and this one as well. So if we use this one and this one, we see that this is what? O, because this is the opposite. So we have O. And when we want to use this one, this is always the longest one, which we call what? Hypotenuse. So it is H. So OH, it means we use what? So we have what? Sine. So we use sine. Then always you come for the what? For the degree or the angle. So we have sine theta, which is equal to O is what? Is x over what? H. And H is given as what? 8. Then to find x, you just multiply this by this. You just cross multiply this, and you have what? Your x standing alone. So we have x is equal to 8 sine what? 60 degrees. Then you point 8 sine 60 degrees on your calculator to get what? Your x. So I have 8 sine what? 60 degrees, which is what? 6.9. 6 point what? 0.9. Approximately what? 7 units. Approximately what? 7 units. So whenever we are given a question of this type, we can solve what? Them using what? Pythagoras theorem or trigonometrical ratio. We solve with Pythagoras theorem. We had what? 7 approximately. We use trigonometrical ratio, we use tan, and we confirm it with what? By sine as well. We all had what? The same answer. So that is what? How we can use Pythagoras theorem and what? Trigonometrical ratio to find the distances or the length of what? Of the triangle. So now we proceed with what? With some trigonometrical rules. With some trigonometrical rules. Now, when we are given trig, you see, trigonometrical ratio does with what? Something we call a Cartesian plane. Or this is the Cartesian plane, and we say, or we can see, this is like the cardinal point here. This is always the North Pole. So we have cos, sine, and what? And tan here, cos, sine, and what? And tan. If an angle fall in any of what? Of these four sub sizes, which is here, here, and here, we have some sign that it takes. To remember, we use what we call cast. Just put it at the back of your mind. This is how we do it. This is cast. So we start from here. This is cast. This is C, A, S, and T. This A means all. It means that when an angle falls here, or it means if you're having what if you're having an angle here, the angle is what? Is positive. Is positive for all what? The trigonometrical ratio. That's why we use what? A. A means all. So when we have what? Sine solution here, cos solution here, or tan solution here, it is positive for all. And this is S. It means that when an angle fall here, or when an angle falls here, only sine is positive. This means only tan is positive, and this means only cos is positive. So if only sine is positive here, then cos and what? And what do we call it? Cos and what? And tan will be what? Negative here. If tan is only positive here, then sine and cos will be negative here. If only cos is positive here, then sine and tan will be what? Negative here. So this is how we do it. Assuming we are given what? So we should just take note that when we are given a trigonometrical, with a trigonometry, we count to the what? To the anti-clockwise. So if this is the North Pole, or let me see, we count from, this is 360 degrees or 0. This is 180 degrees. Here, and this is 180 degrees. And here is what? 270. We count from here and we go anti-clockwise. When we say anti-clockwise, it means we are moving toward to this direction. This is an anti-clockwise what? Direction. So with trigonometrical, we move toward to anti-clockwise. We move toward to anti-clockwise. So if we are given a question like, let me take a question like find the value for what? For sine. For sine what? For sine 120 degrees. Find the value for what? For sine 120 degrees. So when we draw the cardinal point like this, here is 0 or 3 or 60. It means we are reading from here. This is our starting point. This is our starting point. We are reading from here. With the trigonometry, we are reading from here. So we should take note. So we have 120. 120, but we know that here is 90, and here is 90, here is 90, and here is 90. We sum up to what? 360. So when we are going to this side, here will give us 90, and we add what? 30 to 8. So 30. So from here to here is what? Is 120. Then 120 degrees, if you get to 120 degrees, what we are interested in is the rest. The rest of what? Of the angle with what, or the rest of what, of the degree or the angle, which the radius, this is what we call the radius. We term this as the radius. The angle that we are interested in right now is the angle that the radius form with what, with the x-axis. The angle that the radius what, form or makes with what, with the x-axis. So whenever you are given a question like this, that find what, the sine of something or find the tan of something, you trace it to the anti-clockwise direction. Then you say, what is the angle left? Like the angle that the radius, which is what, this line, form with what, or mix with what, with the x-axis. So the remaining here is what, is 60 degrees. Don't forget, it is 60 degrees because we're given sine what, 120. So we're reading what, sine, we're reading what, 120 from this direction, from here. When we got here, it is 90 degrees. So 90 degrees, we add 30 degrees to it to make what, 120. So here is 30. So we added the 30 to the 90 to make what, to make 120. Then it will left with 60. So this 60 is what we are interested in. We are interested in this 60 because this 60 is the angle that the radius makes with what, with the x-axis. So the answer become what, sine what, 60 degrees. Now the sine 60 degrees, we got it from here. So you go to the your cardinal point